This is section 5.3, and we're going to talk about exponential functions. And this is different than what we have encountered before because now our variable x is the exponent. So this is a general form. F of x equals c a to the x. C is the coefficient that might be in front here. The base, a, is what's raised to the variable x. Couple of restrictions here. A has to be greater than 0. Why would that be the case? Well, if a were 0, this whole expression would become 0 and you wouldn't have an exponential function. A can't be equal to 1. Why would that be important? If you have 1 to any power, say 340 or 1 to the second, anytime you raise 1 to a power, you still get 1, and 1 times a number is just going to be a number. It will no longer be exponential that way. And then C, the coefficient has to be bigger than 0 because if you multiply by 0, you end up with 0. So those are the little restrictions that go on there. Here's some examples of exponential functions, and they're written this way, and I wanted to write these because I want you to be sure that we recognize the base. And so in this one it's pretty easy. The base is 3. In this one, sometimes people want to go ahead and multiply those and say that's 10 to the x. The only thing raised to the x is the 5, so the 5 is the base. Likewise here, the base is 1/2. You cannot multiply 4 times that because this to the x power is a totally different expression. All right, let's look at a concept here. All right, when we have a linear function, when we look at these numbers, what's happening to each one? We're increasing by 1. And down here, 2x means we are getting values that are increasing by 2 every time. So for every unit that you increase 1 in the x, you increase 2 on the linear function. And that's what it would look like. In an exponential function up here, we're increasing by 1 for the x, but what happens down here, because this is 2 to the x? That's the difference. This one is 2 to the x. This is 2 times x. And so these increase by a factor of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8, etc. And that's what this looks like. Totally different than a linear equation. An exponential function increases faster than a linear function for large values of x. So it really starts increasing. These come into play when we talk about exponential growth and decay. When you have exponential growth, from left to right, you are increasing, and the growth factor is a. When you're decreasing, when you have a decay, you're doing this, and it's always decreasing. The decay factor is a in this one. This one's always increasing, this one's always decreasing. Graphs of exponential function always lies above the x-axis. That's a horizontal asymptote for this. Okay? All right. Some properties of exponential functions. We've talked about a couple, but the domain, if we look at the exponential function, the domain is negative infinity to infinity, and the range is 0 to infinity. The graph is continuous with no breaks. The x-axis is a horizontal asymptote. There's no x-intercepts, and the y-intercept occurs at the c value. Remember, that's that coefficient there. All right. Let's see. We can move on to our compound interest formula. This formula is compound interest, and we do have some exponential things going on here. So let's look at this. This is the basic formula. These are what each part means. A is the accumulated amount, or the future amount that you have. Say you put $100 in the bank today. What are you going to have a certain time from now? How much is going to accumulate? P is the principal. That's how much you start with. If I put the $100 in today, 100 is the principal. R is the interest rate, and usually if you're doing it by hand, you're going to use decimal form. T is the time in years. So if you were given something in months, you would want to convert that to a fraction of a year. And N is the number of compounding periods. So if the problem said we were going to compound semi-annually, you would use 2 for N. Quarterly, N is 4, annually 1, monthly 12. So those are the parts of that formula that you're going to use. Continuous compounding, we also have a formula for that. A equals the principal times the number E raised to the rate times the time. E is a number. It is approximately 2.7182. It is irrational. It's a pretty special number. You can find it on your calculator using second and the divide sign, or second and the ln key. So we will be using E in these compound interest formulas. We'll also use them with our logs when we get to that. So just take note of that. And then we do have a special one that we're going to look at, modeling half-life. If you've had chemistry, you probably have talked about half-life of certain elements. And so this is a typical half-life formula that we might use. And let's see if you can, I'm not sure you can read it, but it's C times 1/2 raised to, I don't know let's, okay, I was trying to make that where I could see that or let you see it a little bit better, but it is T over K. All right. And the amount of the element is the C, and X is the time in years. I don't know, we're gonna call that T, not X, and K is the half-life of the element. So that's going to come into play in one of our problems, so you'll have those notes to refer to. Let's go ahead and look at our problems and see what we can do with these. Graph the equation on paper and then choose the correct graph. All right, so if you were doing this on paper, you know, we would come over here and we would say X and Y, and we would pick some numbers. All right, so 3 to the 0 power, anything to the 0 power is 1. 3 to the first power is 3. 3 squared is 9. Now 3 to the negative 1 is the same as 1 over 3 to the first power, so that's 1/3. And 3 to the negative 2 would be 1 over 3 squared, so that'd be 1/9. So if we were going to graph those, I'm just going to do this without looking over there. So 0 and 1, and 1 and 3, and 2, somewhere way up here would be 9. Negative 1 would be here at 1/3, and negative 2 would be 1/9. We'd be getting really close. We're never going to touch that x-axis, but you can see that we would be right here. Okay, so I need to get rid of those. So you could do that by hand. You could also go put it in your calculator, but it's really nice to understand how you come up with these values and what that would be. I'm going to go ahead and open my calculator, even though we might not use it right this minute. So we'll just minimize that for the moment. All right, so I think I could get rid of that. All right, following an unexplained decline in the number of birds of prey on his property, a farmer sees a drastic rise in its small mammal population. The function m of t equals 300 times 1.3 to the t can be used to estimate the number of small mammals on the premises within t years if hawks, owls, and similar birds fail to return. So what that's saying, if the birds don't come if those birds of prey are not there, then how many animals are going to be around? All right. All this is a plugging in because you're given some time here. Estimate the number of small mammals in the area 3 years after the birds decline. So you're saying, okay, that's 300 times 1.3 to the third power. You can do that in the calculator. 300 times 1.3 raised to the third power, and hit enter, and you get 659.1. It does say to round to the nearest whole number, so our answer would be 659. All right. Okay, approximate f of x to 4 decimal places. And we're given 2e to the negative 1.1x. Okay, and so we can do this on our calculator. Clear. We're going to do 2. Now to get the e, remember we're going to go to second ln. All right, 2e raised 2. And we've got negative 1.1 times negative 0.09. All right, and that's all up in the exponent. If you don't have a newer operating system and you just have parentheses for the exponent, you need to make sure that multiplication is all in the parentheses. And so we would hit that. It says to round to 4 places. So the fourth place is 4. Next to it is a 6. So we're going to have 5.3825. And again, if you don't have that new operating system with the little box, you would have 2e, you'll get a caret, you'll have a parentheses, and you would do negative 1.1 times negative 0.9 close parentheses. That's the way it is in the calculator. All right, let's do another one of those. All right, and we've got a little bit more going on. I'll write it here for you. We're going to have 1/9 times e to the negative 1.8 minus e to the negative 1.8, and all of that is in parentheses. So let's see if we can put that in the calculator and get it. So for the 1/9, you want to put a parentheses, 1 divided by 9, close, parentheses. We'll get our second ln to get e to the negative 1.8. And then I've got to tab over to get my subtraction. I need another second ln. Now I've got another e, and I've got a negative, well, I don't even have to put that negative. I'll just put a 1.8 because negative makes it. So let's just do this. And come down and close my parentheses. Let's see if I've got everything I need. All right, so hit enter, and it says to round to 4 places, so that's going to be 0.6538, and it is negative. So we will have negative, that one's red, negative 0.6538. All right, number 5. We've got another graphing question, and you could practice doing that by hand, or you could put it in your calculator and get the correct graph. Let's just try one because we haven't done that. We'll clear that, and we will have 6 raised to the x power, and we'll do a graph. And you can see that we get, now this has a different window, So if I did a zoom 4, that's going to get me a little closer to that. You could actually do your 5s on your window and you would get it. But you can see that it is this choice. Same way with 5 to the negative x. Let's see what a negative x is going to get for us. Alright, so here we've got a negative x. And hit graph. Oh, I didn't do a 5. You're going to get the same kind of picture. You can tell, but I should have done a 5, but it is this picture. Okay. Alright. Now let's see what happens to this on number 7. We need to be able to get that graph. So we'll go here and we will put that one in. Clear. I've got 2 parentheses, 1 divided by 11, close parentheses, raised to the x power. Okay, and I'm on that zoom. I need a zoom 6 for this one because these are all 10s. And you can see it came down and is doing this, so it is this C part. Okay. All right, we've got compound interest question. Got several of those. All right. So we've got our formula, A equals P times 1 plus R over N raised to the NT. And let's see what we've got in our problem. $800, 5% compounded annually for 8 years. So P is 800, parentheses 1 plus 0.05 over annually, that makes N1, raised to the 1 times 8. So that's how you would plug that in. And you would have 800 times 1.05 raised to the 8. And if you did that in your calculator, you would get 1181.96 if you are rounding. Okay. All right, let's try this one. 400, 6% annually for 9 years. So we've got A equals 400 times 1 plus 0.06 over 1 to the 1 times 9. And when you do all of that in your calculator, you're going to get 675.79. And that's what goes in the box. All right, let's see what number 10. Number 10's the same thing. Not sure why I gave you so many of those with the same kinds of thing. Whoa. I don't know what I hit there. I'm not sure. I'm going to let you do that one as well. Number 10, you should get 981.79 if you want to check. Okay. All right, let's do number 11 because finally we're getting something different here. This is compounded continuously, and remember that's A equals PE to the RT. $1,800, 9% continuously for 7 years. So we've got A equals 1,800 E raised to 0.09 times 7. If we do that on their calculator, all right, so let me clear that. We have 1,800 times E, so that's second ln, raised to 0.09 times 7. And hit enter. 3379.70 if we round. 3379.70. All right, let's see what number 12 is about. All right, compare investing $1,750 at 8% compounded monthly for 12 years with investing $1,750 at 12% compounded monthly for 12 years. So we've got a couple of different things going on. All right. Let's figure out what we get with the 8% and the 12%. We'll just go over here and do those. So 1750 times 1 plus 0.08 over monthly would be 12. So our n is going to be 12 raised to 12 times 12. Okay? Because that's n times t. All right, and so if you're going to do that one, then you're also going to do 750 times 1 plus 0.12 over 12 raised to the 12 times 12. Whoops. All right, so when you do this one in the calculator, you should get 4555.93. You should try that. And when you do it with 12%, you should get 7333, I believe, 58. Let's see. All right, and so then it says investing at 12% results in how much more in the account than investing at 8%. So what you're going to do there is simply subtract the items that you found. So you're going to do 733.58 minus 45.55.93, and you should get 567.772. And so this would be the answer for that part. And it says round to money. Okay. All right. Number 13 has to do with a particular type of bacteria that's found to be capable of doubling in number about every 49.4 minutes. The number n of bacteria present after t minutes could be modeled by, so we have this equation here. So n of t equals n sub 0 e to the 0.0014 t. So n sub 0 means what are you starting with? What's your initial amount? And t is your time. All right. Approximate the number of bacteria per milliliter after 2 hours. All right, and we're given that n sub 0 is 500,000. All right, so we would do n of 2, because it says after 2 hours, would equal 500,000, because that's n sub 0, e to the 0.0014 times. Now, you have to remember that this is about after t minutes, and you're given hours here. So be sure that you convert that 2 to minutes, that 2 hours, and so you would have a 120 here. Okay, so you're going to do that on your calculator, and you would get, let's see, 268277.986, and it does say round to the nearest thousand. Now you have to be careful, nearest thousand. So here is ones, tens, hundreds, thousands. So if I put enough numbers in there, 26827, oh, I don't, I have another 7 there. So here's ones, tens, hundreds, there's thousands. So if I'm going to round to that number, I have to look here. That 7 is above 5. So this is going to be 2683000. And that's the answer that you should get. So rounding to the 1,000, that's what that means. All right, then it says estimate graphically the elapsed time when there are 11 million bacteria per milliliter. So to do that, we are going to use our calculator, and we're going to go to our calculator and put, we're going to go to y equals, clear out what we got. In y1, we're going to put our original equation here, except that will have an x in it. All right, so we're going to put 500, 1, 2, 3. Is that 500,000? All right, and e raised to the 0.0014x. All right, so we're going to put that. And in y2, we are going to put, what was our question? 11 million. All right, 11. 1, 2, 3. 1, 2, 3. All right. And so we're trying to see, this is going to be an exponential curve, and then the 11 million should be a horizontal line, and we're trying to find that little point of intersection there. So let's see if we can get a window that helps, because we're not going to see it right there. We're talking huge numbers, so we're not going to see it. And I played with this, so I know that my y max needs to be bigger than 11 million in order to see that. So I made that, I think, 12 million. And my y min, let's see, let's put 4, 3. Okay, and x max, let's put it 300. All right, let's see if that gets the picture. I think that's what I was playing with. Okay, I didn't get the right graph, and I knew something was wrong, and now I see what I did. When I wrote this down in purple here, let's see if I can make this work. When I wrote this in purple, I put an extra 0. This is 0.014t. So that's the problem there. And this would be 0.014 times 120. The number, the answer I gave you is right because I did it. I just wrote it down incorrectly right there. And so then I had to go back to my calculator and I corrected it here. And now when we hit our graph, we should get the right picture. Okay, so we're looking for this intersection point, and we'll do second calc 5 and hit enter 3 times. And we get 220.78. It says round to the nearest integer. So we would get 221 would be. So that's saying in 221 minutes you would hit 11 million in the bacteria. All right. So when you start on something like that, remember, I mean, I gave you the window for this one, but zoom 6, if we had started out with a normal window, we're not going to see anything, and you might not know exactly how to do that. If you do a zoom 0, it's actually going to at least give you a starting place, and then you can adjust from there. Let's see, y max is at 11 million, and then I put the 12 million here because I know I needed more, and I knew that I couldn't see to the right, so I went up here and made that about 300. So it's really just playing with it, but Zoom 0 will at least get you on your way to seeing that. All right, and I think that that will do it for this section.